Hello, my name is Alex and I'm from Maths and Physics. Today we're going to be discussing E equals MC squared and what it actually means. So let's get my Sharpie out here. And we're going to start by saying it wasn't originally written like this in Einstein's original paper. It was actually written as M equals E divided by C squared. So, wait, can you see that? Now you can see it. So it was written like this originally. And basically, what this means is mass, or rest mass, so rest mass is equivalent, or it basically equals energy. So energy has a mass. So it's saying mass equals energy divided by c squared. Now, for you who don't know what c squared means the speed of light squared, or 186,282 miles per second squared. So, you might be wondering, how does this make any sense? So, imagine you have two clocks. I'm not sure if you guys can see this. Imagine you have two clocks. One clock is still, and just imagine that the other clock is moving, so it's going around that way. If Einstein's theory, but what Einstein said was this clock here, the one that's moving, should weigh more. Only by a billionth of a percent, but it should weigh more. And why does it weigh more? Well, the clock hand that is moving around has kinetic energy. The springs inside have elastic potential energy, and the cogs winding together are probably heating up, meaning it has thermal energy. So, what does that mean? Why does that matter, you are asking? Well, here's the answer. Energy has mass. Only a very small amount, but it adds to the overall mass of the object. And as I said earlier, only by about a billionth of a percent, but it does. And what he tried to say here was that mass, so that the mass that is combined when you have the energy, so all of these added together, say they all had a mass. If you added all that mass together, and then that mass would obviously be energy as well, because it's obviously the mass of energy. I'm recording, go away. So that would mean that it's that. But then you take that number and divide it by c squared, so the speed of light squared, and that is how much energy is how much the energy contributes to the object. So let me say that again. All of these added up is a mass, obviously. Not very much mass, but it's a mass. And that's obviously energy mass, because it's mass that comes from energy. Energy weighs things. Then you take the mass, divide it by, then you take the energy, or the mass of the energy, divide it by c squared, and that is the mass that contributes to the overall object's weight. So if Einstein's theory is correct, this should weigh less and this should weigh more, meaning that E equals mc squared really says energy equals mass times, and the reason it's times because when you stick two things together it becomes a times, and that's the same in algebra. So with this you had E over c squared equals, and this line here means divide. Okay, with fractions, a quarter, this line here still means divide. That's why when you are converting, I think it's from fractions to decimals, I'm not sure, I think it's fractions to decimals, you divide by, so you would divide 4 by 1 or 1 by 4 to get you, yeah, it would be dividing 1 by 4 to get that, because this line means divide. So, we go back to it. Energy equals mass times the speed of light squared. And the reason it's times, as I said, because there is no line underneath it and c squared is there. It is energy equals mass times the speed of light squared, because when you conjunct two things together, it becomes a times. Say in algebra, I know we're going off subject here, but in algebra, if you had 3b, okay, you don't know what b is, but you know you've got 3 b's, okay. If it was written out in itself, it should be written, that is its conjunct version, but its real version should be 3 times b, okay. So that doesn't mean you've got like 500 million b's or anything. It means you've literally just got 3 b's. Imagine 3 is 1, 3 times 1, 3, it's 3. It's not that hard to understand, but as I said, energy E equals mc squared really means energy equals mass times the speed of light squared. And that's what it means. It's quite hard to understand, but when you get explained, it's not that hard. And I'll give you another example, just to make sure you understand. Say you have a torch. That's not going to fit on. Say you have a torch. It's not a very big torch, but who gives a fuck? You have a battery that has chemical energy in it. What happens to the torch when you turn it on? It loses energy. Yes, it does lose energy, because the chemical energy is being released through the torch, which releases light, and light is a form of energy, so light energy, which obviously releases the energy. So the weight that it loses is not a substantial amount for humans or any animal to feel it, but it is an amount, and we have to take that into a concept when thinking about mass and energy. It's the same with the sun. The sun is a massive flashlight, if you want to put it that way. It radiates shit tons of heat, and it lets out loads and loads of light every second, enough that it actually loses 4 billion kilograms every second. But don't worry, 4 billion kilograms for the sun is not that much. The sun has trillions and trillions and trillions of kilograms in it. In fact, over its entire lifetime, it doesn't lose even half, it doesn't lose even a quarter. But it does lose energy, so therefore it loses mass. Do you get it now? Good. Anyway, I hope you have enjoyed this episode. If you're new around here, smack the thumbs up button. We all really appreciate that. And while you're at it, hit the like button. Me and Alfie are doing videos together now on this channel, and we hope you guys enjoy them. Bye bye.